Perfect. All right, so now it's for real. Okay, all right. So everybody, without further ado, I'd like to present Aaron. Last person jumped in. Perfect. All right, so yeah, I want to present Argenis to everybody. And he's here from Pure Storage. Shout out to our sponsors. And go ahead and do your thing.
Thank you, Frankie. Hi, everybody. This session is going to be all about SQL Server on VMware on Pure. And so I will show you a ton of tricks of things that you can do on the storage side to target different scenarios. By way of an intro, I'm one of the principal architects here at Pure. I work with databases in general, but I go very deep on SQL Server specifically. So I'm gonna kind of tailor all the demos and conversation is around SQL Server today. But the good news is that it applies just the same as it does to SQL Server to other RDBMSs and even other non-traditional databases like Mongo or all these NoSQL technologies. The concepts largely apply the same. So that's it's kind of important to understand that context because a lot of you guys are running, MySQL, a lot of you are running Oracle, and a lot of you are running Postgres. And all the things that I do on SQL Server are equally simple on other RDBMSs as well. So, I do have a little bit of a presentation that I would like to go over. Some basics and some some Pure specific things, but I wanted to keep it very interactive, and everyone has this is not a webinar where people are just listening to me and not saying anything back. So please, if you have any questions, by all means, go ahead and ask those questions. Context is also very important. So if you ask a question at the way to the very end, we may lose some of that vital context to get folks back into it. It'll probably take us longer to do that. So ask questions along the way. That'll be great. And I will share my screen. Let me just log off here from things that you guys don't care about interrupting our conversation today. And here we go. Here's my PowerPoint, and can everyone see my presentation being shared right now?
Yep, we can see it. Thanks.
Okay, great. All right, so a few things here. Again, this doesn't say VMware anywhere, but trust me, we're going to focus on VMware a heck of a lot. But let's go over some fundamentals and why you should care. Specifically for SQL Server, this is something that I like to stress a lot, and it feels that still a lot of VM admins and a lot of storage administrators and a lot of sysadmins and a lot of DBAs don't fully understand how SQL Server works in terms of I/O, like what it does when it issues I/O against a storage subsystem. But I want to kind of highlight the performance and impacts of SQL Server for you guys to kind of digest. But this is true of every single RDBMS, okay? How you format your file system doesn't change how your application actually accesses your file system, okay? It may do so, but not in the way that you think, not in the way that you expect. So for example, on Windows servers, and when you format NTFS file systems, you are going to pick what's called the allocation unit size. And a lot of you guys confuse the term allocation unit size with a block size. You just call it the block size. Let me stress that it is not the same thing. Okay, so when you format your NTFS file system to 64K, which is the recommended for SQL Server, you are not forcing SQL Server to issue IOs of 64 kilobytes in size. If you look at the table that you had in front of you, that shows exactly my point. SQL Server will issue IOs of very different sizes depending on what it's actually doing. If it's writing to the transactional log, it may issue a little tiny IO of the smallest disk sector size in your system, 512 bytes in the case of a pure storage array, but it could be, you know, a little bit bigger than that. It could be 4 kilobytes or even 8 kilobytes in some newer storage systems like you know, fancy PCIe and NVMe SSDs and things like that. You may see a different sector size. Thing is that SQL Server, the smallest write that it will issue is a sector aligned size of disk sector kind of IO. And in our case, it's 512 bytes. So think about that for a second. That's a tiny, tiny, tiny write. But if you're doing a file initialization where when you're creating a database file, or you're restoring a new database, or you're growing your database files, SQL Server may actually issue 8 megabyte IOs for initializing that piece of data on the file system, so, or creating that one file. And so if you think about the implications of that, you can have a tiny IO, or you can have a massive IO, right? It's not a pattern, a consistent flat line of always issuing the same IO size for requests. It doesn't do that at all. The thing of the different operations, having storage subsystem that handles all of these different things, this different IO requests better, it matters a heck of a lot. And so that's something that we're pretty good at. And you get when you start using pure storage arrays, you know, this matters less. But I just wanted to bring that up because I feel that a lot of people are still kind of stuck in the 64 kilobyte SQL Server IO block size conversation, and it's just not the case. Okay, so I wanted to clear that up front, and then, you know, there's your pure storage array, courtesy of my PowerPoint deck. But I wanted to chat today about the things that you can do on the storage side if you to put performance aside. You know, a lot of customers like us for quick bytes in, bytes out. Yes, performance is a great thing, but performance isn't everything, right? It matters a heck of a lot, but what you do with that performance beyond just quick bytes in and out matters even more sometimes. So we have data services on the array that are kind of fundamental for doing a lot of things with databases. So I will chat about all the different services that we have, and so there's quite a lot of them. Specifically when it comes to Flash Array, which is, you know, the device that I have behind me right now, it has snapshots and clones and replication and services that you should be leveraging today for your databases, because they can help you avoid size of data operations, you know, operations that take the size of your entire data set to complete, much easier, and saving you potentially hours and hours of time. Let me give you an idea of what I mean. In the past, or when you're not using one of our arrays, you would typically just take a full-on backup and restore it on a test environment if you wanted to refresh a test environment. And this is a very common scenario out there where you want to feed some data from some environment, maybe production, or maybe you want to, feed some data to multiple, in a scale-out fashion to multiple instances of SQL Server, so that you wouldn't end up around some massive process across multiple instances of SQL, right? This is a very common pattern that we see out there. What if you didn't have to go over an entire backup and restore operation? What if you just wanted to, you know, leverage the data services on the storage side to kind of avoid going over that entire data set? We can do that in the different models of VMware supports for storage. We can do that on a data store environment, a VMFS data store-based environment, a set of VMs. We could do that using VVOLs, right? If you guys haven't heard about our VVOLs implementation, it's actually an industry-leading implementation, where you make things easier or more complex depending on your topology. But largely, leveraging our data services for cloning databases is super simple. So I'm going to give you an idea of how simple it is. And I actually have this query running here. Let me share my screen again because I switched so I can show my face. So let me share my screen again. This is a database that I have here, and I have this workload running against it. So if you look here, there's about let's look at the size of this database here. It's well over 3 terabytes at this point, right? So I have this SP space used on this FT demo database that sits here on this VMO8 instance of SQL Server. This is well over 2 terabytes actually of allocated space on the database. And if you look at the number of rows on this particular table called guinea pig, I'm sorry, I'm looking at VMO9. Never mind that. I want to show you the number of rows on VMO8. So that's right here. I have 7 million rows and inserting and continuing to insert. Actually, 71 million rows on this table, and I'm continuing to insert because I have all of this SQL CMD windows inserting against this database right now. So inserting against that particular table. So you can see that that number is increasing, right? I have this other VM called VMO9 that has a copy of this FT demo database right there. And it has a copy of that database with a completely different number of rows on that table. Right? So if we look here on VMO9, we only have 1,373 rows. So we have kind of a source VM, VMO8, kind of a target VM called VMO9. We have this FT demo database that's several terabytes in size. It actually sits on a 15 terabyte VVOL, but the size of the VVOL doesn't matter. The size of the database doesn't matter. And the workload that you throw in against the database doesn't matter either, right? I'm just gonna use the features that our array has, a flash array has, for cloning volumes, so that I can take a clone of the VVOL where that database resides, 15 terabyte VVOL, on the fly without stopping SQL Server at all, or even telling SQL Server anything. And that'll bring up a usable copy of my database on the target VM, which is VMO9. Okay, so I actually ran the VMFS version of this earlier, and it took about 60 seconds. But if I run the VVOLs version of this, I can actually show you the VVOLs version of this. It took about 4 seconds to complete or so. So let's double check that my database came online on this side. And something happened with my script, so give me just a second here because I don't know exactly what happened. Login failed for user and T anonymous log on. I couldn't. Oh, we have a demo fail here. I guess I changed my script. I must have done something. So bear with me, you guys, while I check it out super quick.
It's a live demo, something's going to go wrong.
Oh, of course, and I just demoed this for a customer and it works just fine. But now I'm
every single time.
I'm demoing this for you guys, and I have all sorts of issues.
At least you weren't trying to throw a rock at the window.
All right, let's do this manually, shall we? So I'm not going to use the script because I don't know what's wrong with it right now, but let's go and refresh this database manually, shall we? So we're going to take this FT demo database on my VMO9. We're going to take it offline. Okay, we're going to drop all the active connections against that database, and that's going to take some time to complete. The FT demo database is now offline, and I have on my disks management, this is the 15, let me just refresh this. This is the 15 terabyte volume on which the database resides. So I'm going to offline it. Okay, now that I have that volume offline, I can go and clone the clone the VVOL that is attached to VMO8. That's this guy right here. I'm going to do it at the array side. So I go into my array. This is my target volume, by the way, VVOL, VMO9, blah, 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 data, blah, blah, blah. And this is my source VVOL, this guy right here. Okay, so I need to go find it on my array side. Let me go to my GUI, go to my dashboard, go to my storage, go to my volumes, look for this guy. That's my source VVOL, right? There it is. And then I want to copy it on top of the other one. So I copy on top of the other guy, which is this guy right here. Just gonna copy and paste this stuff. And I'm gonna say overwrite, okay? Because I do want to make sure that I overwrite everything. See, am I doing the right thing? No, I'm not, because I also have to copy this portion from the source. Sorry about that. So anyway, I go into my GUI and I paste my source VVOL. Okay, this is the container. So this, where is this going to go? Got it. So we're writing this guy. This container is this guy. Okay, so now I got it. This is my main container where all my VVOLs reside, and this is the name of my specific VVOL for VM09. So if I say copy this volume that I just picked on my GUI on top of this guy, if I say copy, it's going to say, are you sure you want to overwrite that volume? And I will say, yes, please overwrite. And then at that point, I am literally done. I can just go into Windows and online this volume here. And you see that my SQL data volume has now successfully come online. I can go into it here and see my database file sitting within that volume on VM09. And now I can bring online my database here in SQL. So let's give it just a couple seconds here for bring database online. And effectively, we have success. And if I want to query my database and see how many rows I have on my target database, I should be able to do that. And effectively, now my target database has 75 million rows, while my source still inserting. I haven't stopped, right? I didn't tell SQL Server anything on my source VM. That number of rows on my source VM is ever increasing. So I just want to highlight a few things here. I did a clone of a 15 terabyte volume that contains a multi-terabyte database that is taking heavy workload. I'm inserting 100,000 rows a second or something like that. I don't even know what the number is, but even 10,000, 100,000, a million rows per second matters nothing, right? This will work the exact same way, regardless of the data size, because we are avoiding a size of data operation, okay? We are cloning this on the fly without telling SQL Server anything, without telling Windows anything, and we're popping up a copy of that data into another VM that could be used for whatever you want. And this whatever you want can be a dev environment. Let's say I don't want to run this nasty query against my data warehouse, so I'm going to pop it into another VM altogether. Do it. I want to test my new version of SQL Server. Get me a data of my current version of SQL Server and attach it to that new version of SQL, just like that, right? I want to seed an availability group replica from a snapshot. That's also possible, okay? I want to seed a transactional replication subscriber from a snapshot. That's also possible. Or just recover my database because something went awfully wrong. I had a snapshot of my database was 5 minutes ago. Somebody dropped the table. I don't want to restore the whole database. Can you get me the data as it was 5 minutes ago? Attach that copy of the database that sits on that snapshot that you took 5 minutes ago. That's a different database name, and just select that data back into your source database. But these concepts are super important to understand. That the gist of all of this is that we're just avoiding a size of data operation. We're just leveraging the data services that the array has on the back end to give you great experiences, right? Avoiding restoring a backup that could take you potentially days. Right? Let's face it, some databases are large enough that it would actually take you days to restore, and save you all of that time using the array-based services. So I will pause here and ask if there are any questions, because I think it's important for everyone who's attending here to understand that you are able to do these seamlessly with every single Pure Storage array without you having to pay for licenses of additional software or anything extra like that. I did this on VVOLs. I'm going to move on to the VMFS scenario next, which is a lot more complex. And you know, I'm happy to answer any questions that you may have in the meantime. Do we have any questions on the chat? We're good.
I have a question.
Yes, Frankie.
So, is there a limitation with using like the amount of VVOLs that you can use within, like, is there a VMware limitation?
So I think there's a limit on the number of VVOLs that we support on the array right now, and I can't remember what the number is. I think if 5,000 is the limit that rings in my head right now.
Okay.
Okay. That's a limit on the array, I think.
Oh, got it.
VMware, I don't know if VMware has a limit on number of VVOLs.
Okay.
A number of virtual disks on, it will be basically the number of virtual disks. I don't know. It's a good question though.
Okay.
I can find out, you know. The number 5,000 rings a bell right now for the number of VVOLs that we support on a single array. That's my recollection of things.
Hey.
Any other questions? Cool. All right, so I showed you guys the VVOLs scenario. Okay, so let's recap it super quick. VVOLs, the way that we implemented VVOLs on pure storage arrays, are basically just volumes on the array. Right? So when we cloned a virtual disk, effectively we only cloned a volume on the array. So I said, this is my source volume, that's my target volume, override it, I'm done. It was as simple as that, because VVOLs makes things so much easier on Pure. But when you talk about data stores and you want to leverage cloning and snapshotting and all these things on data stores, VMFS data stores, you are looking at a completely different pattern, right? Because on a data store, you have all these multiple virtual disks that are kind of embedded within a VMFS data store. And you have all this data spreading across an entire LAN, right? It's not like you have different areas of the LAN assigned to the different virtual disks. No, a data store basically mashes up all the virtual disks within the same file system. And so there is no fixed allocation, anything. So when you perform all these operations at the storage level, cloning and snapshotting, you're not looking at granular operations at the virtual disk level anymore, right? You're looking at operations that entail handling the entire data store, okay? So think about having SQL servers or other RDBMSs that have disks within data stores. If you wanted to leverage cloning and snapshotting within Pure to use those features for, again, whatever you want, you are now looking at cloning entire data stores, right? And that's okay on Pure, because our arrays are data reducing arrays. And the fact that we do data reduction all the time matters a heck of a lot, because when you clone something, you're effectively not cloning anything, right? There is no slice of data operation, it's only metadata and pointers. And this is why we can do all these operations so fast. So if you think about cloning a data store, regardless of how big the data store is, you can still take a clone of it, or take a snapshot of it, and leverage it for whatever you want. And so the scenario of cloning databases on VMFS, it's a little more complex because of how VMware handles things, but not so much how things are handled on the storage array side. So if you start picturing in your head all the series of steps that you would have to take in order for you to refresh a copy of some VM that you have sitting on VMFS, you kind of have to make a copy of the entire data store first, right? Make sure that VMware sees it, or the vSphere cluster sees it as a snapshot copy of the original data store, which involves resignature of that new data store. Then take whatever virtual disks you want from within that snap copy of the data store on your cluster and attach those to the VM in question, or VMs in question if you have multiple VMs involved. And then at the operating system level, you're going to have some files to do stuff with. In the case of SQL Server, you're going to end up with file systems that contain MDF and LDF files, or NDF files, etc. And then you're going to bring up your databases online from that. So refreshing that concoction means a few things. means offlining the database in SQL on the target VM. Remember, we don't really have to do anything to the source systems at all. We can just keep things running, taking heavy workload, and the snapshot will contain a good readable, restartable copy of my database. That's actually one of the coolest things on Pure architectures. When you're about to refresh that target VM, though, you kind of have to offline the database, right? SQL doesn't like it when you change the storage underneath the hood. You kind of have to offline the virtual disk inside of Windows. So on the guest, you have to offline those volumes that you're about to refresh at the virtual disk level, right? You have to remove the actual virtual disks from the VM itself using PowerCLI or some other mechanism, right? You have to remove the previous copy of the data store even from your vSphere cluster because you're about to refresh it. You're going to refresh the entire data store. So essentially, you do all of those things, and then at that point, you can just overwrite with a fresh copy of your source data store. Then, once you're done with that, then you need to tell VMware, hey, you have a new data source. So that involves rescanning VMFS and rescanning storage on VMware. And once you're done with that, you can then reattach the virtual disks to the VM. And then at that point, you can online things in the VM within the guest. So online the volumes in Windows and online the databases in SQL. That's kind of a convoluted process. And it is because vSphere in general doesn't have a great way of handling these things. You have to go through all the resignaturing process and rescanning storage, and all these operations just take time. Okay, the larger your cluster is, the longer these operations will take. So if you have a ton of ESXi hosts in your cluster, the moment you issue a VMFS rescan or a storage rescan, that you're potentially taking a long time to complete that operation. It could take you even minutes, depending. Okay, so it's not a super friendly operation in general, but it does work. It's just it may potentially take a long time depending on your ESXi cluster. So let's recap. Okay, we can do these operations on the back end, regardless of the storage model that we use. And if you guys want to talk about in-guest iSCSI or RDMs, that's kind of a boring conversation because it's the same as VVOLs, right? On our side, bare metal, in-guest iSCSI, RDM, VMO, it's all the same. The only different pattern is when you have VMFS involved. Okay, that's because how things are laid out on disk, really, more than anything else. So I'm just going to demo this for you guys and show you kind of how it works, and I'll show you a script that I have for VMFS cloning, and hopefully this will start the things that I mentioned before will start clicking in your head. But this, by the way, is just a PowerShell script that uses PowerCLI and our PowerShell SDK, as you can see here, for performing the automation. But you don't have to use PowerShell. Okay, you could use workflows within VRAPs to do it. This is a very common thing that our customers leverage out there. I don't have a demo of that, but I'm happy to show you some YouTube videos and give you links to how that's done using those workflows. But this is largely just defining variables, and this is just a demo, so I have some seriously bad security practices on it, as you can clearly see here. Okay, but largely the series of steps that I outlined before are literally listed here in this script, right? We're connecting to the target system that we need to connect to. We connect to connect to a vCenter. We connect to the target database and we offline it. We connect to the target VM and we offline the disk that we need to offline. We remove the disk from the VM, and then we remove. This is actually the call to remove the disk from the VM, and then we remove the previous copy of the data store from the vSphere cluster, and then we connect to the array and authenticate. We clone the volume, right? At that point, when we have removed the data store, we can just clone the volume from the source data store into the target data store, and now we wait for VMware to. We ask for VMware to do a rescanning of HBAs and VMFS, and then we wait for the, once it comes online and say snap copy, we can resignature it and wait for that data store to finally be available and online to, for disks to be attached. That happens here. And then you can just go into the guest VM and online things, right? Online the volume or volumes and online the database or database sets that are involved in the operation. So again, tons of steps because VMware is not, vSphere is not really friendly toward these operations. But on VVOLs, you know, this is 133 lines of PowerShell for VMFS. It's only 41 lines on VVOLs, right? Because you don't really talk to vSphere at all when refreshing a VVOL. That's really something important to understand. That VVOLs makes your life a lot easier when it comes to granularity and you know, clones and snapshots and things like that. But we can kick off. Let me just kick off the workload against the actual vSphere VMFS-based infrastructure. Sorry about that. And then we can take a look at how things go. My VMs that are involved in my VMFS-based infrastructure are VMO1 and VMO3, I believe. So let me just double check on that. This is VMO1. That's my FTDemo database again. On VMO1, which is VMFS-based. Again, space used in this database, you have this much. And on VMO3, there's the copy of the FTDemo database in there, and we have the query to see how many rows we have on that table. Right now, there is no table. Okay, so what we're going to do is, first of all, generate workload against my target VM. And so what we'll do for that is I will switch from SQL CMD from VMO8 to VMO1, and then we'll kick off that workload. That starts inserting into VMO1. Actually, the table did not exist, so we'll go ahead and create it. There we go. We'll switch connections here to VMO1. So the table did not exist, so they should throw an error. And actually, that's not the right database. So the table did not exist effectively, so we're going to go ahead and create it. And we'll kick off that workload that I showed before. Right, inserting heavily into that guinea pig table. And then we can go query on VMO1 and see how many rows we have and kind of show you the same thing that we saw before. So server name is VMO1. You can see 180,000 rows already on it, et cetera, et cetera, et cetera. Ever increasing number kind of thing. On VMO3, remember, there's not even, that table does not exist. And so if we kick off the actual refresh process on that script that I showed you before, this is going to go over all the things that I showed you before, right? It's going to offline things, remove things, refresh things, bring everything back up online. This whole process takes about a minute. Okay, so rather than keep you waiting, I will just make a pause here and ask you, do you have any questions on what I just showed you before? Because I do want to stress a few things after, but before I do that, I want to pause for questions here. All right, sounds like, crickets for now, but I'll tell you this. The same idea of feeding data from one place to the other can be extended into so many other things, right? If I wanted to take all this data and from a SQL Server instance and bring it up online in the cloud, I can also do that, right? We have a product called Cloud Block Store that enables you to have essentially a virtual pure storage flash array in the cloud. And then you can use all these mechanisms that I just showed you, right? Replication, cloning, for having copies of the data up in the cloud, or if you want to migrate things to the cloud, or even bring stuff down from the cloud to on-prem, you could do that leveraging Cloud Block Store. So that's another kind of interesting scenario there. If you wanted to replicate from databases that are as a service in the cloud to some databases that sit on VMs in the cloud and then replicate that down on-prem, you could do that right? So we have some interesting scenarios there for data movement, where you're relying on our replication and not logical replication at the database level, which can be cumbersome and slow and presents all sorts of issues for doing this data movement the pure way. So it makes things a lot easier sometimes, to just have the storage layer handle movement of multi-terabytes of data, as opposed to having the application layer do that for you, right? Because that, I always like to say that block replication will beat logical replication in performance and ease of setup every time. But that is hard to implement sometimes when you're working with inflexible systems. But Cloud Block Store effectively bridges that gap between logical replication and block-based replication in the cloud. So that's an interesting model to kind of pursue there. I believe my script should be done by now, and effectively it is. So now let me start sharing my screen again. And it took 50 seconds to complete. My source database here, VMO1 now has 2.4 million rows, and my target VM or VMO3 has 573,000 rows, which is how many rows we had on that guinea pig table at the time that we make the call. So, that's kind of what I wanted to show you today in terms of data services. But you also want to understand that it's not just between replication of flash arrays, right? We also have FlashBlade, offloading data to FlashBlade is a thing, and replicating between FlashBlades is also a thing. But I don't have a demo for that today, but it will be, I just want to highlight a customer case study that we just saw that was replicating data on S3 buckets between two FlashBlade devices. FlashBlade actually speaks S3 natively, replicating FlashBlade data at 8.6 gigabytes per second. So I thought I threw that number out there because it's actually kind of impressive to see data being replicated that fast between file and object devices. Active cluster is another thing that I kind of wanted to mention here. It's a great way of swinging workloads between data centers. If you want to keep HA between your VMs, it's a great block-based mechanism for replicating data. Active cluster does incur into a little bit of a penalty on the latency side of things, because you are writing to multiple arrays on you're waiting for IOs to be acknowledged and hardened on target arrays before you actually acknowledge those IOs as completed to the guest VMs. But this can be a great way of keeping your data in sync and giving you HA across whether you're talking across racks or across cages or across a metro LAN. The only limitation is 11 milliseconds of round trip latency. It's a maximum that we'll support, but it's a fantastic way of replicating data. And you can actually mash up the different models of data replication that we have. So we have the snapshot-based replication between array A and multiple arrays with active clusters. You could start with asynchronous replication that's snapshot-based, and then end up with a model on active cluster where you are now synchronously replicated. There's another feature that we're going to launch soon that's called ActiveDR. That's going to allow you to do journal-based replication between two pure storage arrays, flash arrays, without incurring into that latency penalty. So that's another thing that you will see us talk about when we release it very shortly. And so FlashBlade is the other part that I wanted to mention, that I mentioned earlier, that I was doing, leveraging its data services for not just snapshot for replication of data. This can be a target for SQL Server backups, right? Tons of customers are using FlashBlade as a target for backups and restores. I've seen databases backed up at 30 gigabytes per second, and I have seen data consumed from FlashBlade at 100 gigabytes per second, right? So there isn't, I have never seen a VM that can handle that much workload, right? So you're talking um, scale out, solution for multiple compute nodes accessing a single flash blade. But this thing can scale ridiculously, and it can literally dramatically reduce the amount of time that it takes you to do anything, including full-on streaming SQL Server backups. We have a customer backing up SQL Server databases at 5 gigabytes per second against a flash blade. That's just one example, right? But it gives you an idea. If you're talking about a database that can that is multiple terabytes in size, not only do you have the snapshots and the clones on the flash array side that will help you avoid a size of data operation and having to retrieve that stream backup that you once took across the network from some other storage device. It may or may not be a flash blade. But also, if you're talking about a regular streaming backup that will take you, that will incur into a full-on size of data operation, you're talking multi-gigabytes per second of for backing up the database, and that will definitely have a big impact on your recovery times. I didn't really have a lot more to show you guys today because I wanted to leave it open for feedback and questions on any other topic that you guys wanted to talk about today. So, with that, I'll pause and just, leave it open for discussion.
Does anybody have any questions for Argenis?
Cool. Well, if we don't, then I am very thankful for you guys having me today.
Yeah, no, thanks very much. Yeah, no, so I decided to reach out to you because when you came on site over to us, I'm not going to say where I work, but when you came on site, you were just, man, dude, the game that you were spitting about SQL, I was like, man, you just know your stuff. It was very impressive. So I was like, I don't know how many of the VMUG members here are leveraging Pure storage, but I just wanted to give people an opportunity to listen to you and just to have a chance to get to know you and like, hey, bring this guy in, because you're just gonna love listening to this guy, because he's very passionate about what he does. So yeah, so everybody go ahead and click the link that's in the chat and register, opt in, give your information, maybe win some headphones. And then Patrick, he's our sales guy. So super cool guy. I've known him for years now. So yeah, let me know if you guys have any questions and I will pass them on over to the team and get you guys an answer. Perfect.
Chances of earning headphones today are really high.
Cool.
Thanks for getting this all set up, Frankie. Appreciate it.
Yeah, definitely.
Morgan, can you paste the link again? Apparently, it didn't quite come through for people who joined.
Yes, let me repaste it. Sorry about that.
Cool.
There we go.
There it is. Perfect. All right, and then the session will be, it's being recorded, so we'll have it on the VMUG channel for later consumption.